Yesterday we have learned how to draw Bode plot. Today we are going to learn how to find the transfer function from Bode plot. Third sum. Suppose you are given an instrument, an amplifier, it may be an amplifier or some instrument. For that, you are required to find the transfer function by experimental way. How we can find? We have to find the frequency response for this. This is the magnitude response. Magnitude response. The table is given. Frequency omega equal to 0.1, 0.2, 0.3, etc. up to 35 is taken. For that, the magnitude in dB is given. The following frequency response test data were obtained for the forward path elements of a unity feedback control system. Plot the data on a semi-log paper and determine the transfer function of the forward path. So if you draw this on a semi-log sheet, it will be looking like this. The black is the magnitude plot. Now we need asymptotic plot, Bode plot. Asymptotic plot is required to find the transfer function. Therefore, we have to draw the asymptotes for this graph. If you draw an asymptote, this is the asymptote. This is the asymptote. This is the this dotted line is the asymptote. Asymptote. The slope of that asymptote is minus 20 dB per decade. And the corner frequency, again, draw the asymptote for this part. So the asymptote should pass through maximum part of the graph. Like that, you have to draw the tangent. That's all. So here, this covers the first asymptote covers asymptote plot covers this much area. Here also, this covers this much area. This much area. So if we draw a line, this is the asymptote. This is the asymptote. This is the asymptote. Asymptote. Second asymptote. Third asymptote, for this part, you have to draw a horizontal line. So now the plot becomes like this. The dotted line is the asymptotic plot. We know the corner frequency. The first asymptote and first asymptote plot and second asymptote plot meet at the 0.5. That is the corner frequency 1, omega 1. One corner frequency we got. What is the slope here? The slope of this line is minus 40 dB per decade. The change in slope is minus 20 dB. So now we'll here this minus 40 dB becomes 0. Here it becomes 0 dB. 0 dB per decade. That's all. Now we will form the we will find the transfer function. The transfer function is here. It is written. We know that it has one S because initial it is not horizontal. It is inclined at minus 20 dB. Therefore, K by S and one denominator first order factor because it has minus 20 dB slope here because of that. Here the change is 40 dB. Here the change is 40 dB. That's why there is a possibility of second order factor or repeated pulse. We have to find whether it is second order factor or repeated pulse. How to find that, we'll see. Now we have to form the table to find the transfer function. The first range is omega naught to omega 1. This is omega naught to omega 1. Range is omega naught to omega 1. Omega naught is 0.1. 0.1 here. This is 0.5. Then net slope is given, that is minus 20 dB per decade. Slope is dB per decade. This is also dB per decade. Minus 20 dB. Again, this is minus 20 dB. Initially, they are slope. That's why corner frequency, no corner frequency. The factor is minus 20 dB. That's why K by S. We have to find the K. Factor is K by S. The next one is slope is changed from omega 1 to omega 2. Omega 2 is where? Here. This is omega 2. Omega 2 is 4.4. Omega 2 is 4.4 from 0.5 to 4.4. The slope is minus 40. The change is minus 20. Therefore, corner frequency is omega 1, that is 0.5. Omega 1 equal to 0.5. Therefore, T1 equal to 1 by 0.5, that is 2. The factor is negative slope, that's why 1 by T1 S plus 1, that is 1 by 2S plus 1. We got one factor. The next one is 4.4 to infinity. That is omega 2 to infinity. 4.4 to infinity. At 4.4 to infinity is 0. Therefore, it is contributed by the factor contributes plus 40. Then only it becomes 0, because earlier it is minus 40. Now it becomes 0, means plus 40. Therefore, omega 2 equal to 4.4 from the diagram. But 40 dB means there are two possibilities. It may be a repeated poles or second order factor. To find that here we see that the corner frequency is here. The corner frequency is here. True plot is here. This is black is the true plot. True plot. The gap is about 5 dB. 5 dB. Minus 5 dB. The gap is minus 5 dB. So asymptotic plot minus actual plot, you will give the error minus 5 dB. The error is negative. That's why it is over-damped system. That's why repeated factor. Over-damped or critically damped system. Damped part. It is not zeta value is not there. That's why it is repeated. That's why we can write 1 by T2. T2 equal to T2 square. 1 by T2 S plus 1 whole square. In the numerator, because plus 40. It is in the numerator. T2 S plus 1 whole square. T2 equal to 1 by T2 square equal to 1 by 4.4. Therefore, T2 equal to square root of 4.4. Square root of T4 equal to square root of 1 by 4.4. That is equal to 0.227. So 1 divided by 4.4. If we take square root of this equal to repeated poles 2.27. Omega 2 is 2.27. Yes. 1 by 1 divided by 4.4 equal to 0.227. Yes, repeated pole. It is not equal to 1 by 4.4. That is 1 by 4.4. That is equal to 0.227. Therefore, 0.227 S plus 1 whole square. Why repeated poles? Because the error is negative. More than about 6 dB. Error means it is repeated course. That's all. Therefore, the transfer function is g of s equal to g of s equal to whether we got k not yet for me. So we cannot write. We have to find k. We got t1, t2. The only thing is we have to find k. To find k, we need two values. Here we know two values. Here, this is 30. This is 40 means 31, 32, 33. At omega naught, the magnitude is, at omega naught, magnitude is 33. So that can be used to find k. How we can find 20 log k by omega equal to 33. Therefore, log k by omega equal to 10 power 33 divided by 20. Omega equal to 0.1. Therefore, k by omega equal to 10 power 33 by 20. K by 0.1 equal to 33 by 20 equal to 33. So 10 power 33 divided by 20. Therefore, k equal to, this gives k value. K is equal to 4.5. K equal to 4.5. 4.5. So k also we know that is equal to 4.5 divided by s. So we got the transfer function. This is the first slope. That's why 1 by s. If first is horizontal line means k only. This is k by s. K by s. If positive slope means ks. You extend that first slope till it intersects 0 dB line. This is the 0 dB line. This is the 0 dB line. The first slope is extended. Extend first slope till it intersects with the 0 dB line, x-axis. It intersects at 4.5. So we can find that way also k equal to 4.5. That way also you can find k. Therefore, the transfer function is 4.5, that is k divided by s, and numerator we have 0.227 s 227 s plus 1 whole square divided by 2s plus 1 multiplied by 2s plus 1. That's all. That's all. Yes. We got the same answer. Therefore, the given transfer function is this. This is the given. This is the transfer function for the given Bode plot. Frequency response. So, how to find? Draw the frequency response, then make it a asymptotic plot, approximate plot by drawing tangents so that it covers most of the points. We got 3 segments. For the 3 segments, we got 3 components. That's all. Another example. Here also frequency response is given. Frequency response is given. Frequency response is given. For that, this is the answer for that frequency response. Here we have drawn that this dark line is the magnitude plot. Then we are drawing the asymptotes. The first slope extended till intersects with the 0 dB line, so that we can find directly k. That is k equal to 200. K equal to 200. The slope here is minus 20 dB per decade. Initial slope, not horizontal line. Therefore, k by s. The first factor is k by s. The next one is it becomes horizontal. It becomes horizontal. The corner frequency is 1.9. The corner frequency omega 1 equal to 0.9. The slope becomes minus 20 to 0. Therefore, numerator factor. Therefore, omega 1 equal to 0.9 means 1 by 0.9. 1 by numerator factor 1 by 0.9 s plus 1. Why numerator factor? Minus 20 becomes 0. This becomes 0 dB per decade. This is second factor. This is first factor, second factor, numerator factor. Then third factor. Third factor, again, it becomes minus 20 dB. 0 becomes minus 20 dB. Corner frequency is 9. 9. Therefore, 1 divided by 1 by 9. S plus 1. So that is third factor. Then fourth factor, here minus 40 dB. Minus 20 becomes minus 20 means another first order factor. The corner frequency is 110. Therefore, 1 by 110 S plus 1. That's all. So 1 by 0.9, 1 by 9, 1 by 110 S plus 1. These are the factors. Then 1 by 0.9 is 1.11. 1 by 0.9 is 0.111. 1 by 110 is 0.009. So we got the transfer function.